Hello, and welcome to this brief introduction of Direct-CSI. My name is Valdivia, and I'm an engineer here at MinIO. I want to introduce you to the topic of Direct-CSI by telling you about the problem that Direct-CSI is trying to address. Right now, let's say you have some applications that are running in a distributed fashion on your Kubernetes cluster, and these applications, they are presenting some type of data service to your other applications. Therefore, these guys need persistent volume underneath. So they'll be claiming this persistent volume storage via persistent volume claims. And in turn, these PVCs, the CSI driver that you have on your Kubernetes cluster, may actually be provisioning from a variety of sources, right? It could be a SAN, it could be on the same device by chance. Usually DevOps and engineers don't really worry about that much. But if your CSI driver ends up provisioning some type of storage that's living on some other drive on some other node. Now, every time your application is accessing a request through your application, you're paying the tax of this network call, right? So this network call is taxing all the throughput and all the operations that are going to your application, right? So this is one of the problems, right? So for applications that are quite intensive, when you have this additional tax, they bring down the overall throughput and performance of the system together. So to address this, we can actually use a specialized structure that Kubernetes supports called local persistent volumes. Local persistent volumes is as simple as mapping a local drive that you have on the node to present it as a persistent volume. And then the Kubernetes scheduler will actually take care of making sure to schedule pods on the same node where the local persistent volume is allocated. Now, this is like a nice solution that you can manually create these local persistent volumes and have them allocate, have affinity to the node where they are actually being modeled for. And this solves part of the problem. But then in reality, your applications don't tend to look like this, right? You're running multiple copies. Therefore, now the more copies of your applications that you need to run, you need to now start managing more local persistent volumes. And in reality, you usually run multiple copies of these applications, all intermingled, right? So you just ask Kubernetes, run this many copies, and you're expecting the storage to just be satisfied. And so in reality, you end up having multiple PVCs requesting multiple local persistent volumes, sometimes on the same disk, right? And sometimes you end up with multiple disks, right? So now if this scenario arises where you're actually provisioning the PVCs that are being allocated and stored in different drives or anything, it becomes complicated or harder to manage. So that is one of the problems, right? So you could try to address the persistence volume taxing problem over the network that I was describing earlier by doing local persistent volumes, but as you are adding more scale, the problem becomes more complex, right? That's the problem with managed local persistent volumes, right? This is something where you will have to develop some very tidy discipline to actually keep the show running and not running into any sort of problem. Now, what Direct-CSI is trying to address is the following. It's trying to keep a constant complexity that grows with scale, that is constant with scale. So if you want to be adding more nodes to your infrastructure, you want to be growing and just be able to say, have your applications request storage that's local and it gets satisfied automatically. So that's what Direct-CSI does, right? Direct-CSI brings that to the table where the provisioning of these local persistent volumes is automatic. Direct-CSI will detect all the locally attached storage to the Kubernetes nodes and it will actually manage it for you. So if I could summarize it, you could think of Direct-CSI as a dynamic local persistent volume provisioner. So that's the best way to understand it, because now in the sense of if you're the owner of the infrastructure, what you're going to be doing as you're adding more nodes to your Kubernetes cluster is just attaching local storage for them and then just letting Direct-CSI take over those, as we'll see in a moment on the demo. And some of the things that make Direct-CSI great is that it's cloud native, it's built only for Kubernetes, it's performant because nothing beats local storage for your applications, especially when you're building very large, very high performance applications that you're running them on your Kubernetes cluster. Nothing beats local storage. And it's very simple. And the beauty about simplicity is that it scales. So that's the three core features that Direct-CSI is bringing to the table. So at this point, I would like to take a break from the slides and then give you a walkthrough through how to actually install DirectCSI, deploy an application. In this case, I'll be deploying a MinIO object storage that's just requesting storage out of Kubernetes and getting it satisfied by some CSI. In this case, DirectCSI will be the one that satisfies the requirement. So let's go into the demo now. So I'd like to start the demo by actually installing DirectCSI, the kubectl plugin, right? This is extremely easy. With any modern kubectl, you can just do kubectl crew install DirectCSI. And this is actually bring the plugin to your local system. Now that after you actually have executed this command, you now can do kubectl DirectCSI install, which will actually install all the required resources on your cluster, as well as detect all the locally attached drives and announce them under the DirectCSI drives CRD. This is pretty much it, and that's it. Now we're ready to go. So now if you type kubectl DirectCSI drives, you can see you have a few subcommands here ready, right? You can see access tiers, format, list the current set of drives, release and unrelease them. So let's do something along the lines of seeing what I have on my system by typing list. So here you can see I have plenty of NVMe drives, as long as other type of devices mounted on my computers. So what I'm gonna do is actually, I'm gonna format all these 932 gigabyte drives, right? So these are partitions on all of these NVMe drives that I actually wanna use. So I'll go with all my drives from 1 to 10 and only that partition 1. So let's do that now. To achieve that, I'm just gonna type a format command. And now this is the command where I'm actually telling, okay, these are only the specific devices that I want you to format, right? And that's it, right? Let's just hit run. That's it. So now let's list the drives again and see what's the status of the drives. I can see that all the drives that I wanted to actually start using and consuming are actually ready for consumption. So that's all I need to do, right? And even if I were to check on my kubectl get storage classes, I will see that now there's a DirectCSI class that I can start using right away in my applications. In this case, let's set up a MinIO object storage application that will actually house some data, and we'll actually be using this storage class. So this is what I want to show you now. So far, we just installed DirectCSI. It immediately detected all the locally attached volumes across all the machines that I have. Now I just format them, right? This made them available immediately to the cluster. So now what I'm gonna do is install, right? So some object storage, just to showcase the usage of this CSI driver. So let's install MinIO really quick. So I'll do kubectl crew install MinIO, right? So this is also gonna bring the kubectl plugin. And now I can just do MinIO init, and this will install the latest MinIO operator. That's it. I even get a suggestion on how to get a nice port forwarding started. So if I run this kubectl MinIO proxy command, I can see that I get a JWT token for authentication and even the nice address that I can just visit on my local browser. So after going to localhost 9090, you're gonna be greeted by a login screen where you can actually paste the JWT token that was granted by the kubectl MinIO proxy command. And then you're inside the MinIO operator UI where you can quickly provision object storage. So case in point, let's do some big data storage for US West. I'll place this on a namespace in Kubernetes, and you can see that I get the list of storage classes that I have available on this cluster. In this is particularly DirectCSI storage class was installed after we installed DirectCSI. So I'll go with 4 servers, let's say 10 drives per server. And right now, let's go with something conventional, 10 terabytes of capacity for the moment. And that's it. Let's just keep it at that. I'll just hit create, and that's going to pretty much give me a set of credentials that I'll be using to access my tenant once it's provisioned. I'll back those up. And now I'll just wait. So now let's go and see what's happening behind the scenes on this Kubernetes cluster. So if I do now kubectl get pods on that namespace that we just saw, I see that my pods are pending. So what about the PVCs, right? So have they been created? Yes, and they're slowly being satisfied, right? I can see all these PVCs getting created. And at the same time, all these PVs that belong to this DirectCSI class are also being created. So now this is all of these PVCs that were requested by my stateful sets are in turn getting satisfied by DirectCSI with these underlying slices of the underlying volume. If you recall, I had 932 something gigabyte NVMe sticks, and now I'm actually getting these chunks of 256 out of those drives, and that's it. right? So as simple as that. Now let's see my pods. They're now all up and running, which is super nice. Now, if I were to go back to DirectCSI and ask it, okay, DirectCSI, what's going on with my cluster? I want to understand how many volumes, how much capacity have you used? I could go back to drives and list them. I will see that immediately out of all these locally attached NVMEs that I have on my system, some capacity is already being used, and there's actually one volume inside of them. Right, these volumes represent the PVs that were created to satisfy the PVCs for my stateful set. But now I have some nice way to understand, okay, what is the usage on which machine, right? So I also get that information. If I want to, I could also go and list the volumes, right? So get a nice list of volumes and see what's going on. I see other applications that were deployed using stateful sets. They are smaller drives, 5 gigabytes. They just requested storage using this storage class, and they were satisfied immediately. And I didn't have to actually go on a per machine basis, selecting, okay, let me slice some of these drives and allocate it and give it to this application. It's all been done for me, right? It's all been automatically by DirectCSI. I don't have to do much in the sense of managing all this stuff. And this is how you actually scale, right? So as you're adding new nodes, all you need to come and tell the DirectCSI is whether you want to format those new nodes, those new drives. And then that DirectCSI will do the rest, right? Your applications only need to start using the same storage class, and that's it. This is how you can scale without complexity, right? So just to summarize what you just saw in my demo, I show you deploying a stateful application, in this case, a MinIO, right? I deployed multiple pods across my cluster. I also had a bunch of nodes, right? And the interesting thing about the nodes that I was showing you during my demo was that they had a bunch of locally attached volumes, different types, right? Specifically in my case, I had 10 NVMe sticks that I wanted to use for my object storage deployment because I want to be performant. And I had some solid state drives or some other type of drives, right? I didn't want to use them, right? So you saw me that when I was actually formatting my drives, I only selected my NVMe drives. I didn't want to use my SSD. They may be the operative system drives. Actually, those won't be shown, but you have the option, right, to create multiple classes when you are using organizing them through DirectCSI to be presented to the application itself. Now, my application itself was a stateful set that was creating multiple PVCs, right? So the key component here was that all these PVCs were satisfied with local persistent volumes. Actually, these are pure persistent volumes, but these guys are actually managed by DirectCSI. DirectCSI dynamically provision each one of these guys, right, and satisfy the PVC. And at the same time, make sure that all these persistent volumes that were being provisioned for the persistent volume claims were together, right, and telling the Kubernetes scheduler, hey, look, whenever you schedule this pod, I need it to be on this node because all its storage is here, right? So we have some nice integration with the scheduler. So any application today, right, doesn't need to have any change in it, right? So only when you're selecting the storage class, that's all that matters to get DirectCSI integrated into your application. And everything that you need to get started is pretty much tell DirectCSI, look, I want you to take either these many nodes or these many drives across all nodes, right? So if you have some infrastructure that looks the same, it's as simple as that. You don't have to do any complicated setup or anything. And this is how you can actually scale very large, right? Now, every time you do a new node, you're going to fire up your DirectCSI CLI and format those new drives, and that's it, right? Applications can now start expanding into those new nodes. So really, you don't have to add any additional complexity, any other piece of software, anything else that you need to manage, because even DirectCSI, once the drives are there, everything is local between the application and the drives. So it's pretty efficient in that sense. So to summarize, what I want you to walk away from this video thinking about DirectCSI is first that this really simplifies the provisioning of locally attached drives. Gone are the days where you actually have to do all of this manual work, right? Scripting the local persistent volumes, etc. You saw it's that simple. So this is ideal for applications that take care of data resiliency. DirectCSI is not going to add some redundancy to the data or duplicate stuff remotely, nothing that old legacy block storage will give you. This is meant for applications that will take care of the data resiliency themselves. This works the same way for bare metal as I was showing you, and as well as any other cloud provider. When you go to any cloud provider and you select one of those machines that have locally attached volumes, they'll come with locally attached NVMe's, SSDs, hard disk drives. You still need to format those guys, right? Manage them and do stuff. DirectCSI can take that work for you, so you get a consistent workflow both for bare metal and cloud. So it has seamless integration with the scheduler. You don't have to do anything else. So just deploy DirectCSI, format, and use the storage class. Done. It's that simple. And lastly, this is designed for IO-intensive applications, because when you really need to squeeze that performance of the hardware, nothing beats direct access to the hardware, right? Nothing beats locally attached volumes. So this is probably the key point for DirectCSI, and this is what I want you to take away. So once again, thank you for your time. Please hit us up on Twitter if you have any questions. Fork us on GitHub. Join our Slack and hang out. If you have any more questions, come and ask us, or go visit our website at MinIO. My name is Daniel Valdivia again, and have a nice KubeCon.